All right, what's up, guys? Welcome to the stream. Hope you guys are all having a pleasant evening. And let's get this party started. Yeah, Brian, I just changed the folders or just updated them. I thought I had done it this weekend, but I did not. So my bad on that. So the biology ones are up. So just go to chapters and then biology. Um, biology of behavior is what you're looking for. So, yep. Hello, Josh. It has been a while. Yes, because you need to have this down still. Hey, Rom. Aaron, you need to know all the neurotransmitters. That'll be your real test, Josh. Do you remember neurotransmitters? The different types? Yes, Juan knows what he's talking about. Yes, all of them. We can talk about them if you want to, but I'm really just going to be like pointing back to what it says on the thing because that's all I really want you to know is just its basics. Yeah, yeah, I can go over all those things. So no, now here's okay. So let me talk about these neurotransmitters. Like you need to know them, and but I don't but just recognize that that's not there's 20 questions on the test and that's not the only thing I'm going to be talking about. It's not going to be the only thing that I ask you. So like don't spend the rest of the night studying over those neurotransmitters. You should have been studying over them the past few days, but I'm not going to pretend that you guys have been doing that. So just you know you need to look over them and you need to know some basics about it, but yeah. Gia, no, there's no FRQ tomorrow. I would have let you know because I would have told you because you would have needed to know your um, whatever it was over. So yeah, Iman, be positive. Remember, guys, stay positive. You got this. Okay. So Nishka, you asked about motor functions. I can go over that. Yes, I can, Monica. Okay. So Nishka, so simply put, remember when we were talking about the frontal lobe, and the frontal lobe had all of those different um, uh, like things that it was supposed to do. It is in control of judgment. It's in control of planning. It's in control of higher mental functions and thinking and stuff like that. And it's also in charge of some of our fine motor movements. And so that's generally in that back top half of the frontal lobe. And that's what's called that's the motor strip. And so what you're going to find is you're going to find that that a lot of movement is coordinated up there. And the more that we do something, the more that we use those parts of our body, um, the more neural connections that we're making and more dexterous we can be with them. So, um, so that's all you really need to know about the motor functions or the motor functions. So, hello, Abina. Yes. Okay. Yeah. Yeah. Let me. Um, Dean, I saw your question. Let me just answer Mukti's real quick and just hop over to the sensory function. Sensory function is just like the motor function. So instead of it being in the frontal lobe, it's in the parietal lobe, and it's at that front part of the parietal lobe. I know I'm pointing generally the same spot on my head, but it's not a big deal. I mean, they're right next to each other. And it's in charge of, like, it's helping us sense things. And certain areas of our body are more sensitive to touch than others. We use those parts of our body to feel things, like when you have a piece of paper or something and you're like rubbing its texture for some, I don't know, maybe it has some texture. um, that's like interesting. You use your fingers, you don't like rub it on your knee or something. um, if you could also like use your face. I know some people who, like, if you like just finish laundry or whatever, it feels nice like on your face or whatever. We have a lot of sensations on these places, and that's why it sucks getting punched in the face. So yeah. And so those are just the two specific areas that deal with those things. So I hope that makes sense. Mukti, let me know if that makes sense. Also, um, that's the first question. Nishka, also let me know if that made sense to you. Um, Josh, yes, still got it, son. You want to take the AP exam again this year, just for funsies? No, Izan, don't worry about locations. Don't need to worry about locations. Okay, so I'm starting at the top. I see a bunch of question guys, so I'm hitting the top and I'm going down. So we're starting with Deanna's question about action potential and the graph. So I'm going to bring that picture up. So give me 2 seconds. Where is my um, okay. I'm just having to transfer you guys over. Okay. So here's the graph for neurons and action potential. So just remember that this graph is showing the message, the process of messages being sent along neurons. And so what you end up having is you're sitting at resting potential, resting membrane potential. I'll always call it resting potential. And the resting potential, simply put, is the baseline. It means that the gun is ready to fire. It means the toilet is ready to flush. It means that the neuron is ready to send a message. Okay. Excitatory neurotransmitters get attached to the dendrites from the neighboring neuron, and then the energy level goes up. Okay, because remember those are excitatory neurotransmitters. It's going to hit that threshold, and once it hits that threshold, the the neuron basically turns on. It's like, okay, we've got enough of a message, and so now I can take that message and send it through. And so you have this burst of energy, and the burst of energy, all that is the message traveling down the neuron. And so what you're seeing, this action potential here, is just the traveling of the neuron, the burst of the neuron shooting, the burst of energy shooting through the neuron, traveling down the axon and whatnot. Okay, when it comes back down, it's not going to go straight back to resting potential. It's going to hit this area number 4, which is the refractory period. And this is a period after what happened, after the message is being sent. It has to take a break. It has to cool down. And you have to wait until your next action potential, or your next thing to get ready to fire. Okay. Woo, woo. All right, you guys, lots of questions. I got this. Okay. Give me a thumbs up if that makes sense to you. And I'll keep going. Okay. Explain the function of the cerebellum. Yes. Okay. So Monica, remember the cerebellum is sitting at the back of your brain, underneath the occipital lobe, and on the underneath the occipital lobe, and like sitting on top of the brainstem. Okay. And so what we have here, I'm pulling up a picture, which I don't think I really need to. But what we have here is we have a part of our brain that is in control of our voluntary movements. And so I like to think of it as like muscle memory, is when like your need to be like balanced and coordinated and to move properly is going to be controlled by that cerebellum. Okay, so you can just like, you have my little personal notes there. You can take a poke at. So Monica, give me a thumbs up if that makes sense. Brian, you asked if you need to know where the motor strip is. No. Ravish, don't remember, don't worry about knowing all of the vocab. The vocab is up, but don't need to worry about that as much. I want you to know the neurotransmitters. So don't, like, you can look at the vocab to look at stuff that we've already talked about, but don't go looking for other things. Okay. Yeah. So, Rahib, so you're asking about the limbic function. Just think of it as the limbic system. Oh, hey guys, and remember, if people are answering questions for me, see, Josh is getting in on this. If people are answering questions for me, you know what to do. Hit them up with that hype train, just so I know that questions have been answered for me. Where's my hype train? Hype train. Josh, we didn't have this back in the day. Hype train these days. Hold on. I gotta get some hype train in. Show you guys what's what. Okay. Um, okay. So limbic system is in control of our emotions. So it's what helps control those emotions. Okay. So what we have, we have the amygdala. Okay. Amygdala is in charge of our fear and our aggression. That's what it's in control of. It's a part of the limbic system. You have the hypothalamus, which is that little space underneath the thalamus, hypo meaning under. It does all of these things, a bunch of stuff: maintenance activities, eating, drinking, body temperature. It governs the endocrine system. We'll talk about the endocrine system probably on Monday, and is linked to the emotion of reward. Okay, so those are the big three things that you need to remember, especially that reward thing that pops up more often than not. Okay, and then you have your thalamus. Okay, so remember the thalamus is grand central station. Basically, information comes from different parts of the brain and have to communicate to other parts of the brain. And so, in order to do that, it goes to the thalamus, or it goes to that part of the brain, then moves to the thalamus, and then goes to the other part of the brain. Okay, that's what the thalamus does. Okay, and finally, we have the hippocampus. Okay, and remember, hippocampus, simply put, short-term to long-term memory, taking information that you have just learned, names that you have just heard, terms that you have just heard, and its job is to process that information into long-term memory. So people with that have had damage to like the hippocampus, they can't make new memories. It's like really bad. So like anything new that comes up, they very quickly forget. So, yep. Okay. So there's the limbic system. Okay, Ravish, just remember that the midbrain is a way of describing the brain, the way of breaking it down into subsequent parts. So once again, we're asking about the midbrain. So it breaks it down into subsequent parts. The hindbrain is like the old, like basic survival functions. The midbrain has like a bunch of random things that you don't need to worry about except for the reticular formation, and the reticular formation deals with arousal, the alertness, awake type of arousal, not the attractive person arousal. And then finally, you have the forebrain, which is at the top of the head, where the majority of that space, and that's like higher end thinking and stuff like that. Okay. All right. Getting through these. Okay. Do we need to know the functions of the neurotransmitters, or just what type it is? You need to know the functions. And Ashley. Why do I have an Ashley? Ashley, am I just a terrible person for not like remembering your name? But I don't like, who are you? Do I know? I don't remember having an Ashley in my class. Well, if I'm a terrible person, I'll still answer this question because it's a legitimate one, but I feel like I don't have an Ashley. If you can clear that up for me, that would be great. Okay. Yes, you need to know the functions. You need to know if they're excitatory or they're inhibitory, and you need to know what happens if you have too much. You need to know what happens if you have too little. You just got to know them. Yep. Josh, you remember everything. It's fabulous. No. So, Karis, great question. So, distinguishing the difference between the medulla and the pons is not something I'm going to have you do. You will need to recognize whether or not it's one of them. So, like, a question might ask for, like, I will never have the pons and the medulla oblongata next to each other in an answer question and have you decide between one of the two. Will be one or the other one in there, and you'll need to be able to pick it out from from other things. But I'll never pair them together because I don't need you to worry about that. Okay. Josh, I'm sure there's nothing against you taking it again. However, I don't think it would do anything. So, all right. Yes, Nathan, I think I already answered your question. Nathan, you're asking about the specific functions of the neurotransmitters. I think I already answered that. If I didn't, ask it again. Do we have to know all that vocabulary? No, Salman. No. Yeah, 07 Ed, we'll go through practically all of it. This chapter's got tons of it. I mean, we've already gone through a bunch. There's just some extra stuff. So, okay. You have to know the difference between, yep. Will the question, will there be questions on where things are located in the brain? No, Mukti, no. Like, I don't care where things are in the brain. Yes, Josh, I changed it. So, thank you for your input, but no, we won't do that this year. I don't care about if they know where the lobes of the brain are, so that doesn't bother me. Okay. Hippocampus. Okay, hippocampus. When you okay, so Ravish, you're asking. Oh my gosh, guys, we have so many questions. I'm trying. I'm so far. I'm so far behind. You have to scroll up like halfway to get to what questions I'm answering. Okay, so Ravish, you're asking about what is an example of the hippocampus. You introduce yourself to someone, and they tell you their name, and then you desperately try to hold on to that information until it seals itself into long-term memory. And oftentimes we're really bad at remembering names because we're thinking about other things or we're listening engaged in the story, and so that just doesn't happen. Okay. Krista, are you answering questions for me? Yes, Krista, thank you. I'm giving you late trains. You answered someone's questions. Hold on. The hype train is late for Krista, but it's still there, Krista. Thank you. All right. Yes, hippocampus is our memory. Can you go over the vesicles and how it relates to the neurotransmitters and reuptake? Okay, so Niall, just remember the vesicles. All you need to know about them is that they hold on to neurotransmitters. So they're like little bubbles, and there are neurotransmitters inside them. That's all you need to know. Vesicles hold on to neurotransmitters only in the axon terminal, and then they dump them out. That's all you need to know about it. Okay. Deanna, I don't know what the 10th slide is. You're gonna have to be more specific about what you mean by the 10th slide. So let me know what that means, so then I can answer it for me. Cerebellum is part of the hindbrain. Yes. Yes, I can give you the dictionary definition for the brainstem. On the I'm Schoology. Okay. So this is it right here. Boop, read that. All is part of the central core of the brain, beginning where the spinal cord enters the skull. Blah blah blah. Regulation of cardiac consciousness and sleep cycle. So all those things that just kind of keep you alive. Bam, that's your brain. Got the medulla and the pons underneath. So easy peasy. Okay. Dude, train hype. Okay, hold on. Do we have to know the specific neurotransmitter? Yes. Okay. Thank you, Josh, for answering more questions. Yes, Juan. Excellent. Juan's telling them what it's like. Yes, you need to know everything. 20 questions. There will always be, Ravish, there will always be 20 questions on the quiz. Less for some reason. Everyone is answering so many questions. I'm so proud of you. This is helping me so much catch up. Trains, hype trains for uh, Krista again. Josh, Insha, yes. Hype train. Juan, yes. Good, thank you. Uh, yes, yeah. Josh is on it right there. There will oftentimes be questions about like what happens when this part of the brain gets destroyed, and like where does that, what ends up happening. Okay. All right. Okay? Okay. Hold on. Give me a second. Give me 1 second. I have to look at something really quick. Give me 2 seconds. Okay. I just checked my student roster and I don't have an Ashley on my student roster. So, Juan, I don't know what you're getting all excited about. Should I know? Ashley, talk to me. Who are you? Ashley, is that Chatad? I don't know. Whoever you are, I don't know who you are. Holla or let me know what's going on. Okay. So, yeah, Ravish, yeah. So basically, no. Now slow down. So like when you see something, information goes from your eyeballs, follows the optic nerve back to the occipital lobe, and then if like today we were learning about prosopagnosia, where that certain parts, certain like faces, um, are part of the association function. Your recognition of faces happens in associated areas. And so the occipital lobe is going to needs to send that information, what it sees, to that part of the brain. And so in order to get there, it has to go to the thalamus first and then up to that area. Okay. So, and think about when you hear something, that same stuff is going to both your Broca's area and your Wernicke's area in order for you to move your mouth properly, in order to speak, and in order for you to understand what you're saying and or what's being said. And all of that goes to your temporal lobe first, and then to the thalamus, and then to that specific area. Okay. Tyler, I'm not sure what you mean by do we have to know what all the pawns control? I'm not sure what you mean. I don't understand what that question is. What's up, Boomer? Oh, you figured it out. Okay, never mind. Okay. No, you don't. So Rahib, you don't need to know the specific voltage for threshold resting potential and all that stuff. It's just I'm just explaining it. Ashley, I'm a terrible person. I'm sorry, Ashley. I know who you are. Hey, I'm just like the worst teacher ever. Did I just lose you? You can give me a dislike for that. I know exactly who you are. I'm so sorry. I'm so sorry, Ashley. Hold on. Let me. Uh, Ashley, I'm sorry. That was my bad. I was. Well, I'm sorry, Ashley. I know who you are. I say stuff to you every day. That was my bad. Sorry. We're just gonna move on. That was. We won't speak of this again, or I won't. I will try to never bring this up again. Yes. Yeah, I know. Yeah, I know. It's bad. It's bad. I'm out of control. I'm just a terrible teacher. Okay. Sorry, Ashley. I was looking up the CHATAD, and I couldn't find an Ashley on my roster, so that's why. Okay, anyways. Okay, so Nabil, so this quiz will be over what the parts of the brain are and what they do, but not where they are. No, I don't care about where they are. So I'll need to know the names, the brain lobes, brain functions, neurons, and neurotransmitters. Is there anything else? Nope. Nope. Anything that we've gone over this week is fair game. Just everything that we've gone over this week, that's what you need to know. Yes, Umar, you are correct. Uh, yes, thalamus is part of the limbic system. Thank you, Ravish, answering Krista's question. Good man. More trains. Booyah! Thank you, Brian. Nishka, listen to what Brian says. He's very smart. He knows what he's talking about. Yes, thank you, Insha. Thank you, Monica, answering Insha's question. Good. No, you got it. It's fine. It's fine. Juan, you ask enough questions in class. Oh, I'm just drinking water today. Just normal agua. Juan, you've met your quota of questions for the day, so I ignored your question. Type it up again. I can't find it. So just type it up again. So, and I'm finally at the bottom, so I'm really excited and I don't want to scroll back up. So Shelly, what do you mean by the concept of action potential? Like, yeah, you need to know that it's the message being sent through. That's what that will not phase me one. Oh, by the way, I totally forgot to grade your test, so I'll have to post that tomorrow. Sorry, bud. So I did tell you I would do that, and then I didn't do that thing because I had D&D club was tearing it up today. 3 dislikes, yeah. We probably need 4. I'll dislike this. Bam. All right, I'm gonna undislike it because I feel like that's kind of silly. All right, I've caught up to all the questions, and it's only 8:30. What up? What other questions you got for me? What else do you want me to go over? The dislikes. Oh yeah. Good to know. I appreciate that, Abina. I also know who dislikes my videos, so like I can like go look it up. Yep. Yeah, D&D club went well today. So we have a bunch of new people, so what's going on? So oh yeah, all those 6 dislikes. I know who you are. I'll go look you up right now before you have time to change it. Oh, let me just jump into the next window. I had a student last year who did it in every video. He didn't think I knew, but I did know. It is on Mondays normally, but we didn't have a Monday today, so there's no such thing as the most important neurotransmitters, Rom. They're all important. Yes. Aaron, that's not how this works. I am not just going to sit here and go over everything. I will answer questions, and if you happen to ask me every single question and we go through them, that's perfectly fine. But until then, I'm just going to answer questions. I am not going to sit here and go through everything just piecemeal. So ask me questions, and I will answer them. Can I go over how blank travels through neurons? What do you mean? Like how energy travels through? Is that what you're asking, Juan? That's smart. And and my dislikes almost disappear, and my likes increase. It's power for you, boys and girls. Power. All right. No FRQ tomorrow, Tyler. Yep. That was smart, Alvina. Smart to undislike. What's my favorite part of the brain? It's a good question, Brian Hilton. What is my favorite part of the brain? I mean, obviously all of it, but I do like the idea of the cerebellum, where it kind of like does stuff for you. Oh, Teddy. Where you, like after a while, it's like stuff that you don't have to think about. So it's like the voluntary, involuntary type stuff. So I think the cerebellum is pretty cool. So it's my fave. Teddy would like to be doing something other than what we are doing right now, which is not going outside and playing. Hey, buddy. All right. Could you please go, Rahib? I went over the association functions earlier in the. Oh no, I didn't. Okay, just remember association functions. You have tons of different parts of your brain that do very specific things. Okay, like the Wernicke's area and the Broca's area, and that is just a way. Association functions are just a way of like explaining that or saying that, like that's what they are, and they are parts of the brain with high end mental functioning. Okay. Okay. So remember, inhibitory neurotransmitters, simply put, so Tyler, I'm answering your question. Inhibitory neurotransmitters, all they do is they bring the energy levels in neurons down. Okay. So they make it that like you have your neurons that are like trying to get excited and trying to send messages, and inhibitory neurotransmitters just bring that energy level back down. The triangle thing. Yeah, so the little triangle things in the synapses, those are just neurotransmitters. One. That's all that is. Those are like it's just the what the little neurotransmitters look like. So, or that, oh no, that's not what they look like. That's just what the diagram showed. For Q tomorrow. That's okay, Kylie. I'm okay with that. Wait, who's your Kylie? Who's your little brother? We can beat him up later, but who's your little brother? What is the? Oh my gosh. Oh no, everyone jumped ahead to get me again. I gotta catch up. I have to find a better way, faster way of doing all this. What is the axon terminal and its function and the synapse? Uh-oh. Okay, remember just Monica, the axon terminal simply holds on to the neurotransmitters. Like it keeps them there, and then what it does is once the energy travels through the neuron and gets the axon terminal, it releases the proper neurotransmitter into the synapse and stuff like that. So it sends the message out. Okay. Shelly, I think I just went over association functions. So let me know if give me a thumbs up, Shelly, if you're good with that. If you're good with the association functions. Do we need to know what happens if something wrong with the lobes of the brain? Oh yeah, yeah. Now, so okay, so like kind of like a tip for the like quiz and tests. Very often you'll run into questions where it's just like this thing is happening to a person and it's bad. What part of the brain is most likely damaged? Like 100% you'll run into questions like that. So, like have a general understanding of like, okay, well, like just be able to think for every part of the brain. Okay, what would happen to this person if this part of their brain was no longer working? How would that affect them? And you'll be in good shape. Yes, Abina, of course they're more application. Yeah, I try to put in as much application as possible. Ravish, thank you for answering that question. Very good. Nabil, no, I won't do that. So, I do appreciate the ahem beforehand. Yes. Titty train. Yes. Yes. Insha, you like so just think of like the aphasias. That's just my way of showing what happens when you don't have it. So I probably won't ask about aphasias, but I'll ask about Broca's area. And generally, once again, if I'm talking about a part of the brain, very often I'll be talking about what happens when it gets damaged or whatever. So it could pop up. So just be ready to talk about Broca's area, Broca's aphasia. Same thing. Yep. Insha, you're asking how it brings our energy levels down. It's not saying specific. What do you? Oh, you're talking about the neurotransmitter. Okay. Okay. So it's not that dopamine like specifically just like brings um like I'd be very careful about talking about saying like the fact that it brings your energy levels down because that's not really what it's doing. What it's doing is it helps like regulate emotional responses. So that's like keeping them on par. Um, so keeping them from like going from being too extreme. Um, so think of that as more what's happening is it's like regulating stuff. I think if that makes sense, let me know. That's more what I'm trying to say. Oh, did I read Little? Wait, Kylie, that's your brother? Oh man. Oh, why did I read Little? I don't know, Kylie. I don't know why I read Little. No way, Corbin's your brother? No, Krista, Corbin was the bomb on here. That guy, if that guy got all the hype trains, he would answer so many questions while we were doing this. Like Corbin was great. Yeah, he was like, I there were lots of questions that I would just like that I would get to, and he'd already like fully answered it. So no, I got mad respect for Corbin. He did great. Okay. Nabil, somebody a hype train for Nabil. That's a good pawn. That's awesome. Yeah, joke trains. uh, okay. So in the chart we looked at with like the four parts. Is the third part when inhibitory neurotransmitters are active? Tyler. So in the chart we looked at with like four parts. The third part when inhibitory. What are you asking, Tyler? Um, the if you're talking about the columns, column two is asking. Wait, Tyler, I have no idea what you're asking. Go back and ask whatever you're asking again, because I'm totally clueless with what you're trying to ask me. Yes, Karis, you need to know the problems and deficits with the neurotransmitters. Yes, thank you, Krista. You're on it. Is there a difference between reuptake and refractory period? Yes, Aman. So think of those as two. Hmm. Yeah. You could say they probably happen at the same time. That while once the neurotransmitters have been released, that period of time is when the neuron, like right after they get released, because that's the action potential being sent down, and then once they get released, the neuron is now resting, is now in that refractory period, and so technically my guess would be is that the neuron is back to resting potential by the time it's really getting back into um, its refractory period. So I think technically refractory period happens after, or the reuptake happens after refractory period, but I wouldn't worry about it. That's not something that you need to know. But it is a very good question. Okay, so one, if the midbrain were to be damaged, what would be the result? Because people in comas have their. So Juan, remember, when don't like I'm probably not. I will. I'm not going to ask you a question about the midbrain. I'm going to ask you a question about the reticular formation. I just want to help you categorize the different areas, and that's the way that it's done. That's the way that the scientific community like categorizes them and puts them together. Um, so yeah, so a person with reticular formation damage, often like people who have um, not insomnia, not sleep apnea. What's that disorder where people like fall asleep suddenly? Why if I'm blanking on this? Oh no, I have to look it up now. We'll talk about it next week. But there's a disorder where people just suddenly fall asleep and then they have difficulty staying asleep. I'm be so mad that I have to look this stupid disorder up. What is it called? Narcolepsy. Yeah, people with narcolepsy oftentimes have damage to their or that thing. Yeah, to the why can't I remember it? To that part that deals with our arousal. Yep, reticular formation. Whatever, Kylie. Corbin's the bomb. He's weird, but the good kind of weird. You'll appreciate it one day. You'll appreciate it one day. Yep. Yeah, Monica, reuptake is just the recycling of neurotransmitters. Okay, neurotransmitters go out, attach themselves to the next neuron, the dendrite, and then once they've dropped off their message, they come back, they get back into the synapse, and then they go back into the axon terminal just to revamp and go again. Krista answering questions. Yeah, Krista, you're the bomb. Keep it up. Okay. Okay, Tyler, you're asking when the graph is going down, is that when the inhibitory neurotransmitters are being used? No, no, that's just the spike at the end. Like, your energy level pops up and then, you run a mile and then after a mile you're really tired. And so your energy level goes back down. Nope. No, no, no. It's just like you need a burst of speed to get through and go all the way down the axon. But you don't, but that's it. Yeah. Do the pons and the medulla both have respiratory system? No. Wait, what? What do you ask, Ravish? What are you saying? Like, do they both help with the respiratory system? Yes, and that's fine. Like, different parts of the brain do different things, and sometimes there's an overlap. So yes, Ravish, they both do it, and that's why I wouldn't ask you like a question to compare the two differences because it's annoying. Yep, you could say that. Yes, Sabina. Yes. Motor strip and motor cortex are the same thing because people can't come up with same things. Yes, Karis, you had it. It was narcolepsy. I should have read. Uh, sorry. Teddy is taking. He's back to laying down. I will bring him back at the end of the stream, maybe. Okay. Sweet. Good work, guys. All right. So, you guys have more questions? Because if you don't, I have some questions for you. Bum bum bum. Bum bum bum. Let's see. Ooh, here we go. Bark of protest. uh, there's no bark of protest. He appreciates the love and attention. Okay. So my day was great, Nathan. Thank you for asking. It'd be funny. I'd love to bring Teddy. I think isn't Deanna? You might know this. Isn't Oh, did you hear your name? What do you want? The masses call for you. Come on, Teddy. There he is. Okay. So, after message is sent out. Yes, Neil. Yes, thank you, Brian. Okay. No, I haven't really taught Teddy any tricks, but he knows like quite a bit of basic commands. He knows when to sit and to heal when we're running together, and he knows ball. That's his favorite command. So if we're ever like, because he loves playing fetch, and so we will. What are you doing? I'm. He's over here trying to get me to pet him. Like, yeah, fetch and stuff like that, and um, you know, I never taught him any like goofy tricks or whatever. But he does good. He comes when he's called and sits, and yep. Well, Vina, you missed today. Can I get a quick rundown about what we learned in class today, like just the basics? Uh, Today we talked about the higher end of the brain. So we talked about like the cerebrum and the cerebral cortex, and then we talked about like a lot of. So we spent a lot of time talking about association functions, and then we talked about plasticity, and that was it. So, yep, yep, yep. Yeah. I can ask you the questions. Yeah, I've got some practice questions. Okay, so these are kind of awkward to do. Let's see if I can do this in here. Is this too many words? Sometimes this won't let me. Okay, hold on a second. Okay. Okay. So here, Brian, you take that back. I noticed that you have League posters in your room. Do you play it? I do play it. Nathan, I haven't played it as much as I used to. I used to play it a bunch, but I haven't played it in a while. Okay, so here's a practice question. Um, Walking down a dark. So basically, the way this works is I'm gonna post like questions and stuff up, and then you just try to answer it. So you have a description here, and all I'm asking is what part of the brain is most likely damaged. Yep. So remember, Juan, when you say hindbrain, you're talking about an area, not like a specific place. So, Karis, yes, that's what I'm looking for is the brainstem. You could say the medulla as well, but more specifically, it would be the brainstem. There you go. You're on it. All right. All right. Here we go. Next question. Bam. Okay. Answer this. I need to see in the chat. You need to answer these questions for me. Guys, do not use like Do not use midbrain, hindbrain, or forebrain for an answer. I'm looking for very specific places. Amygdala is what we're looking for, guys. Look, this, yeah, fight or flight right there. Yes, Deanna. Like you're getting mugged in the street. You got a guy in a hockey mask at 2 o'clock with a huge knife jumping out at you. That's fight or flight, baby. You're running or you're fighting. All right, here we go. Next one. Good. Amygdala is what we're looking for. It's all good. It's all good. Yep. Good. Yep. 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 His hearing would be affected. Good, 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 good. All right, here we go. Neurotransmitter question. Good luck. This is what a question. Oh, you know what? No. I wouldn't ask that question. Don't even worry about the neurotrans. Ooh, stop. Nope. Never mind. I won't be asking that question yet because I want you to know more about drugs before you answer it. So let me go back. Don't even worry about that question. I'm not even going to talk about it. Okay. But I am going to ask another neurotransmitter question. This is another neurotransmitter question. Sarah's grandfather has developed Alzheimer's disease. Can you tell what can you tell about her probable changes in brain chemistry? So what it's really asking is like what neurotransmitter is been affected here, and what's wrong with it. What happens when you have Alzheimer's disease? What's happening? There's too little ACH. Yep, acetylcholine. It's pronounced acetylcholine. When you don't have enough acetylcholine, you run into people with Alzheimer's. So that's in my future. Woo! Very likely to have Alzheimer's disease. It runs in the family. Okay. Good. All right. Next question. I'm glad you like this review, Deanna. I mean, I usually have these types of questions for each unit, but you guys have been the last couple times have just had so many questions. It's good. No complaints from my department that I just haven't had a chance to get to these. Mm-hmm. Okay, good. Now, it's specifically Wernicke's, remember, because Broca's is just talking about the mouth and motor movements, and Wernicke's aphasia is like everything. Okay, it's like language composition um, and expression. Well, you have to know about the specific areas that we talked about. One, yeah, everything that we've talked about is fair game. Yeah, so Krista, go back. Ooh, hold on. What is this saying? Difficult. No, it says it's. Wait, are you asking a question about what I'm saying? Yeah. So if you reread the question, it says after Martin's car accident, he had difficulty understanding what others were saying to him. He could speak, but what he said made little sense. That's Wernicke's. That's totally awareness. Yeah, you need to know the two areas, Juan. That is super fair game. Okay. Oh, yeah. Okay. Krista, you were answering a question for me. I appreciate it. Okay, next question. Okay, this one I have to split into two parts. No. Ooh, hold on. Is enough? Okay, hold on. So this is put into two questions. So here's the first part, and here's the second part. Now there's one specific in this situation because look at what's happening in the situation. If you get this one, yes. Booyah. Very good, Maggie. Very good. Yes, good, good, Rom. Good, guys. If you can answer this like this type of question, like legitimately, that like good, 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 good. Like that's very good. Yep, excellent. Norepi, norepinephrine. Good, good, good. Okay, that is what I'm talking about. Uh, All right, so here we go. So I've got another question. We are doing great. Yeah, it's I might be lagging. I'm sorry, guys. Ooh, I hope that's not. Is that how bad is it? Ooh, I'm sorry. I'm sorry about the lag, guys. I don't. That's ridiculous. So okay. So here we go. Next question. Can you? Is it too bad? Okay. Here we go. Next question. Are we okay? All right. Oh, we're good enough, guys. Okay, so you don't need this to be like great sound quality slash great image quality. All right, so here's your next question. The chat only allows you to have like 200 words or whatever, or 200 characters. So I can't put big questions in all at once. Hippocampus, guys. Hippocampus. Remember, hippocampus is short-term memory into long-term memory. Yep. All right, here we go. Next question. Good. Hippocampus. Good, 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 good. Deal with the lag. You'll survive. All right. First part of the question. I think I have to break this into three parts. Yes, I have to put this in three parts. Okay. There you go. I'm not going to. I will say it is on, but I'm not going to type it in. Yes, we'll choice Insha. Our 21st birthday. Oh my gosh. Yeah, this internet's really bothering me. Okay, hold on. Let me fix this right here. It's lagging too much. Oh, hold on. Okay. Well, give me a second. Okay, just dropped a personal hotspot, so let's see if that saves it. Hello, Teddy. Yeah, I know. What is going on? Why are you not catching? Okay. No, likely not. Yeah. Your frontal lobe would be like would have an issue here, but is this work? Am I okay? Oh no. All right. Okay. Hotspot save the day. Okay. I'm gonna ask just a couple more questions, and then we're gonna call it a night. Um, hmm. Hotspots. Okay. So here we go. The one before was the no, the one before was the cerebellum. The question that we just got asked was the cerebellum. Yep, cerebellum. Okay, there we go. Next question. If he was struck by lightning, he's looking down, lining up, blah 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 blah. Hits his occipital lobe. What's going to be damaged? Okay, good. Sight. All right, here we go. Last one. Last question. Coming at you in a couple parts. Okay. All right, there you go. Last question. Here we go. What do you got? Good. Remember, Karis, don't use midbrain, hindbrain, or forebrain as answers. And it's not like the midbrain and reticular formation. Guys, remember the midbrain and the hindbrain and the forebrain are just ways to categorize, like it's just to put it in a section. That's like saying that my elbow like is part of my arm. The elbow is what I need you to know, and it's just part of my arm. Does that make sense? That's what I'm talking about. So when I'm like the midbrain, that's a section of my brain, and I need you to know about the reticular formation. Is that okay? That's what I need you to know. Yeah, it's the reticular formation. Okay, I'm out. Do you guys have any questions before I skedaddle? Anything you guys want to know? Yeah, remember, reticular formation is just in charge of our arousal, our alertness. And remember, we talked about this. Like, if people who have damage to their reticular formations have struggle to stay awake, and that's what we talked about with narcolepsy. Um, no, no, Niall, unless you're talking about a specific lobe, no. Yep, yep. There you go, Deanna. Thank you. Okay, well, I am out of here. Teddy needs to go run around or something. So thank you very much, guys, for hopping on the stream. Good luck studying tonight. You guys should be pretty good. Just make sure that you know the neurotransmitters. Don't stay up too late. But otherwise, y'all have a great day, and we will see you tomorrow.